Hi everyone, welcome to West Explains Best. Today I'm doing a special video called Dividing Exponents. This is a worksheet from Math Drills, and this is based on request. I had a viewer, M2G, request this video because he wanted something that had negative exponents. So I want to go over negative exponents real quick. I'm going to highlight those problems. So that's 2, 3, 6, and 7. Maybe we can get to number 9 if we have time. But I want to quickly review some of our power rules so we know what we're doing with this worksheet. So the first thing is, if we have exponents, so we have exponents here in this fraction, and that's one of the rules we can have is if we're dividing, okay, if we're dividing fractions or powers, sorry, not fractions, what we can do is if it's the same base, here it's 3, here it's 3, we can subtract the exponents. So really it becomes 3 to the 5 minus 2 power, which is going to be 3 to the third power, or 27. Okay, now if you are not with this up to speed, that's okay. This is, again, requiring some background knowledge on exponents, some division rules, etc. So if you're looking for negative exponents, that's why I'm assuming that you have this done. But if not, let me know in the comments. I can make it a little bit more clear or do another video for you. So here I have 3 to the 5th power. That's another way to think of this. Instead of subtracting exponents like this, and the reason why you can do that is you write out 3 to the 5th power, which is 3 times itself 5 times, 3 to the 2nd power, which is 3 times itself twice. And what I like to do is I like to just cancel. So I cancel 1 from the top, 1 to the bottom, and we're left with 3 in the top. That's 3 times 3 times 3. Technically, 1 is left in the bottom, and you get the same thing, 27. Okay, so that's one way to think about that. Now, the next thing I want to talk about, again, this was the one thing I really wanted to highlight today because it's negative exponents. Most common mistake people think that this equals is they say, oh, this must mean this is negative 9. That's not correct, okay? That's a misconception. This negative exponents is just another way to write it as a fraction. It's a more simple way to do it. It came about with computer language, okay? So writing it with negative exponents is a more simple way for coding to process information instead of seeing it in fractions. That's why it exists. It's easier to type in a calculator. But anyway, so what it represents is if we have 3 to the negative 2nd power, really means 1 over 3 to the 2nd power. One of the things I like to do is if you see this, negative 2, that means you're going to continue this and then move that 2 to the bottom and then put a 1 in the top. I don't know, it's just kind of like a little thing I come up with just to know if you see that line, that means you're going to be putting it as a fraction, okay? So this really is 1 over 9. More complicated example, what if we have a negative exponent in the bottom? It's the same thing. It turns into a fraction, but now we have a compound fraction. So what we're going to do is multiply by the reciprocal. So this becomes the reciprocal, 2 times 3 to the 1st power over 1. That's the same thing as 2 times 3, and that's 6. Okay, another way I like to think of it is anytime you have a negative exponent, what happens is it moves either from the bottom to the top or the top to the bottom. Up here, put it over 1, it moved from the bottom, or sorry, from the top to the bottom, and here it is in the bottom now. If it's a negative exponent in the bottom, it moves to the top, so this becomes 3 to the 1st power, and again, it vacates that area, so you have to leave a 1 there, and now we have 2 times 3, 6. That's another way to think about it. So let's go ahead into these problems. First, we see 9 to the negative 7 over 9 to the negative 7th. The first thing I said is that we can subtract the exponents, so we can have 9, because the bases are the same, negative 7 minus a negative 7. Okay, you can subtract exponents with the quotient rule. I didn't list that out specifically for the vocab, but that's what it is. And we get 9, whoops, that's one ugly 9. 9 to the 0 power. Negative 7 minus a negative 7, that's technically a plus. Negative 7 plus 7 is 0, and we get 1. And it should be 1 because if we have the same thing in the top and bottom divided by itself, no matter what, that's going to equal 1, and that's the way we can check that answer there. Let's go on to another negative exponent problem. Here we have negative 2, taking a negative 8 power, and then we can subtract because we're dividing, okay, as I said before, by 9. Okay, this time we're subtracting by 9 and not by negative 9. So we're going to get something a little bit different. We're going to have the negative 2 still, and now we're going to have, for an exponent, we're going to have negative 17th power. Okay, so negative 2 to the negative 2 to the negative 17th power. It's always good to write it with positive exponents. I don't know if it says it here. It doesn't. It's kind of assumed we want to write it with positive exponents. You usually don't want negative exponents written as you're solving. So we write negative 2 to the 17th power. We should put that in parentheses because that's a negative 2. Otherwise, it'd be 2 to the 17th power and then make it negative, not negative 2 to the 17th power. And that's going to be our answer. It's kind of a funky answer, but that's what it is. You could calculate that in your calculator to negative 2 to the 17th power. You're going to get something huge, but that's not super important here. Here for this one, it's the same thing, top and bottom. Okay, it's going to be 1. Okay, we know that, but just to show you, negative 7, that's our base, top and bottom. It's the same. And we're going to have 7 and then minus because we're dividing here. Okay, dividing means we're going to subtract with the quotient rule. And we get negative 7 to the 7th minus 7 power. That's negative 7 to the 0 power, and that's 1. Okay, so anything to the 0 power is 1. I didn't go over that, but that's one of those things you need to know also. Let's change the green just for the fun of it. So we have negative 6, to the negative 3 power divided by negative 6 to the 4 power. One way we could do this, we could have same base, negative 6 to the minus 3 minus 4. Okay, so that's one way we can think of this problem. Or we can think of it like this. Okay, just so you can get the hang of it, we have negative 6 to the 3rd power, and we could put it over under 1 because, again, it moves from the top to the bottom when there's a negative exponent. And then we'd multiply it by 1 over negative 6 to the 4th power. Okay, either way, negative 3 minus 4, negative 6 to the minus 7 power. Okay, and over here we'd get 1 over negative 6 to the 7th power. These are the same thing. So this value and this value are the same. Negative 6 to the negative 7 and 1 over negative 6 to the 7 are the same thing. But we should write it as a positive exponent. So really, this is going to be your answer. Again, to make a positive, you move this. Whoops, that kind of got away from me. 1 over negative 6, and you make it positive once you move it. Okay, don't just put it in the bottom and keep it negative. I see that a lot also. Don't do that. So there's your answer for that one. Here we go. There's this one. What I would do is, 4 to the negative 6, and we can subtract 0 because it's the same base, and then dividing. And we get 4 to the negative 6, right as a positive 1 over 4 to the 6th power. Okay, that would be your answer there. Or you can just see, okay, this is going to be 1. So we have 4 to the negative 6th power divided by 1. This moves it to the bottom, and then it becomes positive. So 1 over, it's vacated, so it becomes a 1. 4 to the positive 6, once we move it, we can make it positive. This is the bonus one. I'll go ahead and do it. Negative 2 to the negative 4. I'm just going to go ahead because the same base. Top and bottom, and then I'm subtract 3. I get negative 2, parentheses, don't forget my parentheses, to the negative 7, and that would be negative 2 to the positive 7 if we put it under the denominator, because these are the same thing. That's how you work negative exponents. So really, they're not that bad. Again, this can be found on math drills. Okay, they have tons of useful resources. If you want to check out that website, there'll be a link in the description below. But again, this is a video based on requests. So if you have more videos that you want done for math drills or any other resource Khan Academy, you just let me know, leave a comment, and I can hook you up. So thanks for watching this video, and I look forward to seeing you next time right here on Wes Explains Best.